If you haven't done so yet, please pause the video and attempt to solve the question before listening on. We know that the period of a pendulum depends on the following equation, where L is the length of the string that makes up the pendulum, and G, of course, is 9.8 meters per second squared. What we need to do is solve this equation for the length L, and to do that we could perhaps first divide both sides of the equation by 2 pi. We would then square both sides so that we can get rid of the square root. Notice that when we squared 2 pi, we squared both the 2 and the pi to make 4 pi squared. And then we just need to multiply both sides by g to solve for the length L. Now at this point we could just plug in the known values. Again, g is 9.8. The period in part A is given to us as being 1 second, and of course 4 pi squared is just a constant. So when you plug in those known values and compute the answer, you should obtain approximately 0.25 meters, and if we need to change that into centimeters, we can just move the decimal over 2 places to the right. So that would give us an answer of 25 centimeters, the correct answer to part A. Now for part B of the question, it's basically the same thing except for the value of g, which is going to be changed to 3.7 meters per second, since that is the given free fall acceleration on Mars. So all we need to do is change 9.8 to 3.7, and then we're good to go to calculate the length. And when we compute this, we get a length of approximately 0.094 meters, which in centimeters terms becomes 9.4 centimeters. And that's the correct answer to part B. Now for parts C and D, when we have a mass suspended from a spring, we can use almost the same equation to calculate the period, except we have to change the term L over G to M over K. We would then solve the equation for M in the exact same manner that we solved it for L. So here we have the equation solved for M. Notice that G does not appear in this equation. So for both Earth and Mars, we're going to calculate the same mass. All we need to do is plug in the spring constant, which was given to us in the question. The period, once again, is 1 second, and then 4 pi squared is a constant. So we'll just plug in those known values and we'll get the answer. And again, that will apply to both parts C and D because the gravity is not a factor in this equation. And when we compute that mass, we get a value of approximately 0.25 kilograms, and that is indeed the correct answer to both parts C and D. Thanks for taking the time to watch the video. If you liked it, please click that thumbs up icon and also subscribe to the channel so you can stay tuned for additional videos. You are also welcome to send your own question into this email address, and I'll do my best to post a video solution to it on YouTube.